Hello and welcome dear students. Here I am going to start the next topic. In this topic we will understand how to solve numericals on the refractive index. Dear, let's discuss about our last class. In last class we have studied about refractive index. Just I am recapping it by writing the formula and then we will move to the numerical problem. Okay dear, just to understand what is the meaning of refractive index. Dear, as we know that when light travels from one medium to another medium, it bends. Okay, and that bending phenomenon is known as refraction. Okay dear, and the bending ability of the medium is called as refractive index. How much it will bend. Okay, the bending ability of a medium is called as refractive index of that medium. Means higher will be the refractive index, more will be the bending of light from its original path towards the norm. Okay, if there is a less refractive index, there will be less bending. If there is a what in comparison to first medium, second medium is rare medium, the bending will be away from the what norm. This is how just we had to discuss today, because we have deeply studied in the last class about refractive index. Just we have to understand it. What is the meaning of refractive index? What do you mean by absolute refractive index? Okay, so dear, understand it. Refractive index. First of all, we have to understand refractive index. As we know that refractive index is represented by mu. Okay, and this mu, what it means? Okay, just to understand it. Okay, dear, the speed of light in a vacuum divided by the speed of light in any medium means the ratio of speed of light in vacuum upon the speed of light in any medium is called as absolute refractive index. Dear, we can also say it as it is a relative refractive index with comparison to vacuum. Okay, so we can also state it as absolute refractive index or what relative refractive index with respect to vacuum. Okay dear, so here refractive index will be equal to speed of light in vacuum upon speed of light in medium. Speed of light, speed of in vacuum upon the speed of light in medium. Okay dear, let's suppose that the speed of light, I'm not supposing, it is speed of light in vacuum is represented by C. Okay, C upon speed of light in any medium. Let's suppose that it is V. Let's say that V is the speed of light in any medium. So V. So in short, refractive index of a medium is C upon V. Okay. So dear, it depends on the speed of light in that medium. It means that the speed of light in that medium is higher, the refractive index will be what? Should be lower. Okay, if the speed of refractive index in that medium is lower, it means that the refractive index of that medium is higher. Okay, so diamond has the highest optical refractive index. It means that light enters, when light enters in the diamond, it becomes slowest. Okay, means its speed decreases. Okay, I hope you get idea about dear. So we have a formula. refractive index is equal to speed of light in vacuum upon speed of light in any medium. Okay, V is the speed of light in any medium. Okay, just here. Have another approach. Just understand it. What it means, absolute refractive index. What? Just have another experience, another way of experiencing it. You may also write it as, we understand, refractive index of medium with respect to what? Vacuum. Vacuum, you may vacuum or air. It is a similar speed in air or in vacuum. Almost it is a similar speed. So we can say that what? Vacuum in any medium, the refractive index of any medium with respect to air is C upon V. Okay, where V is the speed of light in that medium or C is the speed of light in air or vacuum. I hope you understand it. It is a general thing. Okay. Now I am coming to what? Let's suppose that there is a two medium, medium 1 and medium 2. Okay. Let's suppose that there is a two medium 1 and medium 2. Let's suppose that this is the medium 1 and this is the medium 2. Okay. This is the medium 1 and this is the medium 2. Light just entering from medium 1 to medium 2. So, how we can find refractive index of medium 2 with respect to medium 1? How we can find? Just to understand that. As we know that refractive index of medium 1 will be equal to mu 1 with respect to air. We can write it as C upon, let's suppose that V1 is the speed of medium 1, speed of light in medium 1, and V2 is the speed of light in medium 2. Again, refractive index of medium 2 with respect to air, you may write it as C upon V2. Just to understand, this is the basic formula. From this formula, I am just changing the value and just making it. Okay, dear? Just changing the value and just making it. V1 is the speed of light in a medium 1. That's why refractive index of medium 1 with respect to air is C by V1. Refractive index of 2 with respect to air is what? C by V2. Okay? I hope you get an idea about here how to change this equation according to our needs. Okay, now I am moving to further. Okay, I have to find refractive index of medium 1 or medium 2 with respect to medium 1. Okay, how do we understand it? Just here. Refractive index of medium 2 with respect to medium 1. Okay, just I am writing here. Refractive index of medium 2 with respect to medium 1. Okay, just divide it. Refractive index of medium 2, C upon V2. Okay, C upon V2 upon. Okay. Refractive index of medium 1 with respect to here, and here. You may remove it or have it. Okay, because here is always same, speed is same, that's why. Okay, so C upon V1. Okay, C and C will cancel out by refractive index of 2 and removing it. Okay, both are same value and removing it. Okay, so C upon V2 into V1 upon C. C and C will cancel out. This will be a refractive index. This can be written as, just understand here, refractive index of medium 2 with respect to medium 1. Okay, that is equal to V1 upon V2. Okay, V1 upon V2. Okay, why V1 upon V2? Why not V2 upon V1? Do you understand? As we know that refractive index is inversely proportional to speed. Inversely proportional to speed. That's why refractive index of medium 2 is just lower. Inversely proportional to speed of what? Light in medium Why? What again? Refractive index of medium 1 with respect to what? Medium 1. That's why here it is become a formula. And how we will read it? Just read it, understand it. We call it refractive index of medium 2 with respect to medium 1. Refractive index of medium and start writing medium 1 2 with respect to, I am also writing inside W for with respect for R and T for 2 with respect to medium 1. Just we will read it. So in similar manner, if anybody will ask you how we will read it, this will become refractive index of medium 1 with respect to 2. Okay, what will be its formula? Just it will be changed, V2 upon V1. Okay, how you will read it? Just understand here how to read it. Refractive index of medium 1 with respect to 2. Refractive index of medium 1 with respect to medium 2. Here I hope you understand, you have an idea about this formula. So we have a relation between the speed of light and the refractive index of that medium. So now I am going to move and do some numerical problem that given in your book. Okay dear, just have it and understand it. Just I am okay. So just focus the question and understand it. The speed of light in vacuum is 3 into 10 raised to 8 meter per second. It is given that the speed of light means C is given. C is 3 into 10 raised to 8 meter per second. You understand? The speed of light in vacuum is 3 into 10 raised power 8 meter per second, and the speed of light in a medium means V is given. Any medium, okay? V is given, that is 2 into 10 raised to 8 meter per second. Okay? What is this? The speed of light. The speed of light in vacuum. What is this? The speed of light. The speed of light in a medium. In a medium. Okay. Just I have represented it by V. Okay. What is the demand of question? Means what is question asking? Okay. So find the refractive index of the medium with respect to vacuum. Okay. It is asking about refractive index of the medium. Index of medium with respect to vacuum. Okay. What will be this? Okay. So we have a formula, refractive index, that is absolute refractive index. It means it is the absolute refractive index. That is the speed of light in vacuum upon the speed of light in a medium. Okay. So just put in mu is equal to what? C upon V. Just have a simple formula that I was explaining earlier. By putting the value, you will get the result. Mu will be equal to C. C is 3 into 10 raised to power 8 meter per second. Here, similarly, 2 into B has the value 2 into 10 raised to power 8 meter per second. Meter per second will cancel out. 10 raised to power 8, 10 raised to power 8 will cancel out. Mu will be equal to 3 upon 2, that is 1.5. Okay, it is a unitless quantity as it is a ratio here. It is a ratio, the meter per second will be cancelled out, so it is a unitless quantity here. Okay, now we will move to next question. Okay dear, what is the next question? The speed of light in a vacuum is 3 into 10 raised to power 8 meter per second, and the refractive index of the medium with respect to vacuum is given 1.4. Find the speed of light in that medium. Dear, it is the same question, similar question, but there is a change in data, small data. Okay, this was the first question. Okay, in the second question, what is the change? Okay, just have it. It has given refractive index. Okay, it has given refractive index. Means mu it is given. Mu is 1.4. Mu is 1.4. Okay. Now it is asking what the speed of light in that medium. Okay. The speed of light in that medium means question speed of light in medium. It is the demand of light. Okay. So as we know that refractive index is equal to speed of light, speed of light in vacuum. Vacuum upon the speed of the light in medium. Okay, so here it has given mu is 1.4. The speed of light in vacuum also given 3 into 10 raised to 8 meter per second. We are not knowing about V, the speed of light in that medium. Okay, just have some mathematical. So we will get an answer. Just move it here, and 1.4 will move them down. V will here 3 upon 1.4 into 10 raised to 8 meter per second. Okay, this will be answer. So you will calculate it by just dividing it. You will get the result, that is 2.14 into 10 raised to 8 meter per second. Okay. Okay dear, I hope you understand it. I hope you can able to solve this type of problems. So try to solve it from any question. I will provide you in the next class some question on it, and you have to solve it. Okay, bye dear. If you have any problem, please feel free to ask that question in Google Classroom and Google